Welcome back to Let's Build a Tetris-Like. I've got a lot to cover here. I did a lot of work, but I haven't been able to make a video because my dog had surgery and I've kind of got to like sit on the floor with him and take care of him and stuff. It just hasn't really been easy to make a video. But I was able to sit around with my laptop with him and write a lot of code. So let's get into it. These are the ones that I finished. And I think last time I set up where I'm getting an angle from the in-play tetromino to the player movement. And so let's look at that one first. There has been one minor change to that. Let's fire this up first. It might take a second, so I will pause the recording. Okay, let's get back into it. So, the first thing I did was I added some debug lines here. You can't see them yet. This is actually, I extended the bounds of the player board. The reason for that will become clear in a moment. But the thing is since I want to allow you to move the tetromino up, down, left, and right, it was possible for the player to actually lift the tetromino out of the play area, and then it would drop. It would no longer collide with the bottom. And but when you are in this view, the cursor can't get up high enough here, and I'm still blocking it. The other problem that solved, I used to have one across the top, a blocking volume. I used to have one across the top, but it was causing issues where when the new tetromino would spawn in the top center point right here, if it didn't have enough room to rotate, it would just stay in the position that it was in. So as you'd move the tetromino back and forth, you wouldn't be able to rotate it if the tetrominos had been stacked up to about, within 2 or 3 blocks. So that fixes that problem. I wrote a similar game like this. It was written in C# using monogame, which is basically just a branch of XNA, if you're old enough to remember what XNA is. But anyway, so that's the differences that you're seeing here right off the bat. The next thing is so when you bring in a new tetromino, I have the debug line set up here to show the 8 different directions that the input can take. So it'll be a little difficult here. Actually, there's an easier way to see this. So I'll get to this in a moment, but in check set revert. 1 second while I find it. All right, here it is. I'll get to this in a moment too, but I refactored the movement here. So a lot of this code was repeated across move left, right, up, and down. So I just pulled that out into its own function. I'm passing in the direction in the previous position, and then the set position is what we're grabbing there. And if it collides with anything, I set it back. But what I wanted to show in here is I set up a buffer, and I'm going to increase this to do it like 300 right now. And what this buffer is doing is when the tetromino moves towards the cursor, once it gets there, since it's moving 100 units at a time, it is going to never be able to get on the cursor itself. So once it would get there, the tetromino would start flipping around and going all crazy. So I set up a buffer. I'm increasing this now to show what I was doing with the debug lines. So let's run back over here. All right, so now the thing shouldn't move around as much. All right, so previously, I think it was in the last video, I had this set up that if you cross one of these 8 different directions, they were invisible before. Over here in this angle to input, it would show a number. I think I was showing degrees before. But But I changed this, so you'll see that right now I'm at 0 and I'm crossing this line and it's not changing. That's because I changed the rotation to be offset by half of 45 degrees. Since I'm basically just setting up a buffer that if I want it to move right, I want it to be plus or minus, 22.5 degrees, and not like if the cursor is down here and to the right, the way it was set up before is it would just check if it was between these two 45-degree directions, and then it would be moving to the right. So this just offsets it so that the buffer is kind of in the right place. I basically just rotated the input by 22.5 degrees, half of 45. And now, depending on where the cursor is, it'll just have that little buffer. So it changes at about the halfway point between 0 and 45 degrees. And it does that the whole way around. And this direction between 0 and -4 and 0 and 4 is what I'm using to pick which move function I'm getting at, or that I'm trying to get to. All right, so that's what those debug lines are for. All right, I think we covered everything. All right, so we got the angle to input. Now we'll look at the move. So for movement, this is over. I don't think I had these in here in my last video. So I set up 4 different functions, and it's basically just, move left, right, up, or down. And all that's happening is I'm grabbing the current location. This is in tetromino base. So whatever tetromino is there, it will have access to this function. And I'm just calling it previous position because this is what I'm using to set it back if there's a collision and it can't resolve it by rotating. So I'm getting the actor location, I'm setting it into a variable, and then I'm taking that position and I'm moving it in the direction by the size of one block, and that's 100 units or 100 centimeters in Unreal. And then I'm passing in the previous position, and then I'm going through here, I'm checking the buffer, we'll set this back, and then I'm also checking that if it's dropping or not. And the reason for this is that if you lift your finger off the button, the input, whether it's touch screen or mouse like I'm using right now, if you were within this buffer and you stopped adding the input, it would just stay where it was and it would never call the drop function, which is handled elsewhere in here. So I had to set this up like, if it is dropping, I still want it to hit all this code, regardless of if it's within this buffer area. So that's why we have an OR here. Oops. Yeah. So if it's within the buffer, or if it's outside the buffer, don't do any of this stuff. Or if it's within the buffer, you don't want to move it. Or if it's dropping, you still want to move it. All right, and then so we're grabbing the previous orientation, then we're setting the position. I think I had this one before, yeah, because the tetromino was moving. So set position, all this is just setting the actor location and then setting the block positions. Since the tetromino itself just consists of 4 blocks, I had to set the actor of the tetromino, and then this set block positions moves the blocks in line with the orientation and position. So we're setting the position, and then if it's not dropping, we want to call the find best rotation function. And what this is it's an auto rotate. Let's grab this in the Trello So that's this one here. On mobile, I don't like in like Tetris clones and stuff how it usually has something like you have to swipe down and like tap the sides of the screen to rotate, and then it'll still just fall as usual in regular Tetris. What I like to do is have it find the best rotation where it tries to get all four blocks as close as it can to the player input. So if I have the cursor here, let's grab the drawing thing. Okay, so there we go. So if we have the player area, there's a tetromino. We'll say it's the T piece. So, and my input is here. Well, you have four blocks here, and so what I'm doing is I'm taking the average distance from each of these blocks to the player input. So here, 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 and here. So I'm taking all those distances, I'm dividing it by 4 to get the average, and then I'm storing that in a variable. So now that we have the visual out of the way, let's hop over here. So I'm going through the 4 different rotations that there can be, or 4 different orientations, I mean. I'm rotating it clockwise, and then I'm checking if it is not colliding. I'm grabbing the average distance of the 4 blocks. And then if that average distance is less than the previous best average distance, which here I'm just setting to a very large number so that it will always be less than that, no matter where your input is on the screen. And I'll show you why I'm doing that in a moment. So then after that, we're just setting the best distance to the old or to the current one, and then I'm setting the orientation. And then I feel like I need a set block positions in here. Oh no, that's happening in rotate clockwise. That's right. Let's just double check that. Yeah, removing the orientation, normalizing the rotation, and then set block positions. Yeah, so that's all good. All right. So then we're finding the best position. If we do find one, we're just gonna skip. I'm not sure if this should be a return. Maybe it should just be a continue. Oh no, yeah, because this one is looping the 4 times. So if I do find a best rotation, then I want to return. If not, I want to check if we're colliding and revert it. There's a chance we're still not colliding. It might have already been at the best rotation, but we're checking that here. So let's go back into find best rotation. So after all that is done, after you loop the 4 times and find the best orientation, if the best average distance is still 10,000, that means that I'm like inside a wall or something. So I'm just going to set back to the previous best orientation and then set the block positions. And then I'm going to return false because that means we did not find the best rotation. Otherwise, we're going to go in and we're going to set the orientation to the best orientation, and then we're going to set the block positions, then return true because that means we did find the best orientation. All right, so that is my if statement. Actually, this video is already at like 15 minutes. So what I will do is, since this video is getting so long, no, auto rotate. Oh yeah, we just did cover auto rotate. So we're moving towards the player input and we're doing the auto rotate. Next, we'll talk about the refactoring that I did. Actually, you know what? I think that's all we have. I probably can do that in this video. All right, one moment while I set up what I'm looking at here. Okay, so I'm a liar. I moved this one over, but I only briefly went over the move code. So when we hit the not you. Find best rotation. Oh man, I didn't realize how much I did here. Check set revert. Oh, no. Okay, I can't remember which one this is. One moment again. It's probably because I named it set direction. All right, so not only is this setting the direction, I should probably change this name. This is why you use descriptive names. So I'm setting the direction, but it's also setting the move timers. So let's change this to set direction and move timers. Should take a second. It's taking a while. But anyway, so we're passing in the direction after we get it. Oh, it's asking me. Yeah, I didn't realize how many different places that one's actually being used. Actually, we're already over 15 minutes, so I think I'm going to end this here, and then we'll pick up with the move timers and stuff in another video. I hope you enjoyed it. I'll see you in the next one.